Sometimes it's useful for us to create what's called an initialized array. And what that means is we're creating an array that is pre-populated with some kind of values. And what we're going to see here are a few different ways we can do this. We're going to use the A range, which is a lot like range, which we saw before, especially when we were writing for loops. We would do for I in range 10, and that would iterate over the values 0 through 9. We can do the exact same thing, but in the context of the Numpy library. So A stands for array, range, and it really looks the same way. We can also use ones, which is a function which initializes an array of ones. And then for those who know linear algebra, or those who are interested in machine learning, a really popular technique in data science and business analytics, you often need to know, I shouldn't say often, but you need to know a little bit of linear algebra, and the identity matrix is a useful concept to know about. So we're just going to introduce a couple of these things to see how they work. So here I can initialize a one-dimensional array of the values 0 through 9. So it looks just like that. So that's much faster than writing every single value. In the next one, I can create a two-dimensional array where each row looks like what we just created. So we can do this over and over again. We could also store that as a variable. We could store the NP A range 10 as a variable and just have a whole bunch of them in an array separated by commas. So that's a faster way to make a two-dimensional array / matrix. Couldn't think of an application for creating an array of ones, but it's a function we can use. That's what it looks like. And then the identity matrix has zeros everywhere except for across the diagonal. So in this case, we're creating 10 rows, 10 columns. The identity matrix is always a square matrix. So the 10 specifies the dimensions of rows and columns, and then int is just, I decided to make these integers. It made sense. So then some mathematical operations we can do with matrices, just to get a little bit of a sampling for what you can do. Let's create an array. So this is what I was talking about. We make a variable called AX, and it's a range of 0 through 9. I could reference that AX over and over again to create a two-dimensional array. So, and then I print it. And here I could just multiply all values by 2. So that's what happens. I can do other things. I could do AY plus 2. That would add 2 to each of the values. And you can probably extrapolate from here that any mathematical operation you apply to that matrix is going to be applied to all the values in the matrix. We come across something called a dot product sometimes, and again, this is for those who might be interested in doing machine learning at some point. And here we encounter the transpose, again, just for the sake of this example, specifying an array with some basic numbers 1 through 9 arranged in 3 rows. And I'm going to also use the transpose, and the transpose is the same matrix but rearranged according to rows and columns. So instead of 1, 2, 3 as the rows, I have 1, 2, 3 as the start to the columns. So some of you may have encountered a transpose before, others not, but again, it's really just for the sake of this example. So the dot product is a mathematical operation that you can do with matrices, and we won't spend a lot of time on it, but you should just know that it's there, it's an option. And of course, there are many, many, many more matrix operations that you can do in the Numpy library, and all you would have to do is look up the documentation for Numpy to get a better idea of what you can do. All right, next section here we have selection of elements from a Numpy array. So this might remind you a little bit of SQL, and there are multiple extensions from here. So the first part is just creating an array of floats. It's just what I decided to do for this example. It could be integers, that would be fine. So here we form the array as we have been doing. And then here is an example where we just illustrate the process of selecting all values that meet some criterion. So I'm applying the modulus operator to each value in the matrix and seeing if the modulus is equal to 0. So we've seen before that that's a way to check that if a number is even. And then I have two additional arguments here. The one is going to take the place and sort of function as a true if the number is even, and then 0 could represent a false if the number is not even, if the number is odd. So here's what this would look like, and here it is. This is the matrix that gets returned, so you can see that it checks the 0, that's even, then so we get a 1 for that number, and then 2 is even, so we get a 1. So basically turning the matrix into a matrix of zeros and ones, which sometimes is preferable to true false, because then we could work with it mathematically. So some of these things underlie, again, more complex operations and more complex tasks like machine learning. Some other things that are really good to know about are random number generation. So here are some examples of how we can work with random numbers in Numpy. And again, this is just a sample. You can look at the documentation to see even more. So here's an example where I want to take 10 random integers from the range 0 through 9. So usually the amount of things we want to select is the last argument in the function, and then the first two in this case are a range. So this is going to give us a series of 10 numbers that are randomly selected from the range of 0 through 9. So I'm going to do some commenting here just so we can view each of these one at a time. Kind of a helpful tool we have for running programs. I'll leave these alone, those won't interfere with anything. So let's just run this and see. And I did not print it, so okay, there we go. 10 random numbers in the range of 0 through 9. Oh, I see what I should be doing actually. I think I should just comment these out so I don't have to print every single thing there. Okay, so here we can specify the values as an array output. So I've randomly selected 9 numbers but arranged into a 3x3 array, and each of those numbers is randomly selected from the range 0 through 9. So those are all integers. If we want floats, we can use the sample. And something's not happy. Oh yeah, because I had that print before. Okay, go away. All right, so here this gives me an array. This is what the sample does, because usually it's not used to just select one value. It's usually used to select multiple. So if I just use the sample to get an array, a 3x3 array of random numbers from the range of 0 through 1. So there could be applications for this in simulations. Another tool we have is the random normal distribution. I don't know If you've come across that in a statistics class before, you may have good or bad feelings about it, but another useful tool for simulation. So this takes a random value from the standard normal distribution, which is a normal distribution with a mean of 0 and a standard deviation of 1. I could also take 10 of them, and it gives me an array. I can also, this is a really classic example that uses IQ scores as an application, mean of 100, standard deviation of 15. And the way to work this with the random number generation is to specify the mean and standard deviation ahead of time. You don't have to do that. You could put the numbers in directly, but I find this a little bit easier to read. So I set the mean equal to 100 and the standard deviation equal to 15. And then I know this is kind of weird syntax, but I can say mean plus standard deviation, then I'm using the multiply symbol times the random number generation. So I select actually 100 observations from the standard normal distribution. So yeah, that actually makes sense mathematically, because what I'm doing is I'm multiplying all of those standard deviations by the actual standard deviation of the distribution. So that works. Okay, so then we have some exercises that you can do just to practice some of those skills. Again, this is a very cursory overview of what can be done with arrays in Numpy. If you find yourself needing to do more, you can always dig into the documentation. But these basic skills are kind of necessary before moving forward.